We're back with day 83 after our big test. Today we're looking at the area of a bounded region. This will be a precursor to our unit that has to do with bounded regions. We will find areas of them. We will find volumes of these regions revolved around different axes. And we will let the areas be the base of a solid that we're going to find the volume of as well. But it really helps to get a basic understanding of the area of a bounded region. So to start, I'm just going to show you an example here without any specific functions or specific numbers involved to get this key concept down. Conceptually, it's going to be very important to understand what's happening here in order to solve these problems. So I'm going to start with a sketch. Okay, so here's an XY axis, and I'm going to sketch two functions. This blue function is the function f of x, and this, I don't know what color that is, this function is called g of x. And my goal here is I want to find the area of the region bounded by the functions f of x and g of x. Bounded means like it forms a complete boundary, right? So it's like the fenced-in area between these two functions. So what I'm looking for here is I want to know what is this area. Okay. Sometimes we'll only have two functions that bound a region. Sometimes we'll have three or four. Sometimes it's, two functions plus an axis, or two functions with two vertical lines, something like that. We'll just start with a simple one with two functions here. Okay, so what I want you to think about right now is how the heck are we going to do this? Conceptually, I think we have the ability here to figure out how to do this using tools that we already know. So what I want is the black region there in between those two functions. I want that area. Well, we already know how to find areas under curves, right? So think about how you would do that, right? Predict in your head right now. What are we going to do to get this answer? What kind of things do we need to know? Well, in thinking about this, it's going to be really important to know where those two functions intersect, right? This point right here and this point right here, the two intersection dots there are going to be very important. So, and those are points, right? So they have x values and y values. But what's going to be important to us right now in this particular problem is its x value, right? So we need to figure out where those two functions are equal so we can find those intersections. Right now, I'm just going to call the x value here A, and I'm going to call the x value here B. Okay. Now, what I want you to think about is how are we going to do this, and why are we learning this right now after we've done so much work with definite integrals? Right? Definite integrals have been a big, important factor here. Why are we learning this now? Well, remember back in like Principles of Math, one of the things, or grade school, one of the things that we worked on was finding the area of a shaded region, right? And we oftentimes found one area, found another area, and then subtracted them. That's exactly what we're going to do here. So let's think about the blue function here, f of x. If I did the definite integral from a to b of f of x, what would that give me? Well, what it would give me is the area between f of x and the x-axis, right? The area under the curve. It would give me from here to here, right? So the integral from a to b of f of x would give us this. Okay. That would give me all of that area. Now that is not the same as the area of the black that I'm trying to find, right? It's not the same as the bounded region, okay? But it includes all of the black plus some extra stuff. So I'm going to start with that, and then what I'm going to do is have to subtract, right? I need to subtract all of, like if you follow this eraser here, all of this region down here is overcounting the black area up here. So what I want to do is figure out what can I subtract away that will be this bottom shape right here. How can I subtract that away? Well, this right here, this region is exactly what the definite integral of g of x would be. Right? I'll sketch that in here. The definite integral from a to b of g of x dx, that number answer would give me this region right here. So what do I need to do with the integral from a to b of f of x and the integral from a to b of g of x? Well, what I need to do is I need to subtract those two. So what we get from this is the area of the bounded region is always going to be the definite integral from the endpoints of the region, right? In this case, a and b, right? I do the definite integral of the top function minus the bottom function. I always have to do top function minus bottom function. In this case, the top function right here is f of x. The bottom function right here is g of x. So the area of the bounded region simply equals the integral from the left endpoint of the region, the left x value endpoint of the region, to the right endpoint x value of the region of the top function minus the bottom function. Now, these can be split over two integrals like they are here, or they can be combined to make one integral right here. When we solve them by hand, sometimes it's easier to put those two together in one integral. Sometimes it's easier to split them into two. When we do it on our calculators, I always combine it into one integral, just because it's less typing into my calculator. Okay. What I want you to know is it's not always f of x minus g of x, right? Here's how I think about this in my head. Scary place to be. In my head, I think of this as the integral from left to right of top minus bottom. Okay? That's how I always think of it. The integral from left to right of top minus bottom. If g was my top function, it would be g of x minus f of x. F was my top function, it'd be f of x minus g of x. But it's always the integral from left to right of top function minus bottom function. So what I'm going to do is I'm going to do two examples of solving this problem. One is going to be a no calculator problem, one is going to be a calculator problem. For me, these are a million times easier with a calculator. Okay? You just have to understand the concept and be able to use your calculator. They're a lot more difficult in no calculator. Okay, so let's start with what I think is the harder of the two, no calculator. Okay, so here's the no calculator problem. Find the area of the region bounded by y equals x squared and y equals x. Okay. So those are my two functions. They'll create a boundary, right? There'll be a region bounded by these two functions, and I need to figure out the area of that region. Okay? And I'm going to do that simply, I'm going to do integral left to right of top minus bottom. The problem is, I need to get an idea of what the heck is going on. So, without a calculator, what I like to do first, it can be a tough skill for a lot of people, what I like to do first is get a rough sketch of what these two graphs look like. Now, thankfully, they're pretty easy things to graph. This can be more challenging when we have, trig functions or more difficult quadratics than simply x squared, things like that. So let's take a look at a graph. Now I know that y equals x squared looks like an upward-facing parabola that has a y-intercept of 0. Sorry, that doesn't really, let's make that just a thicker bar. I always like to label them so I know which one's which. That's y equals x squared. Then I want to also graph y equals x. Well, that's linear. Once again, it has a y-intercept of 0, and it has a slope of 1. So it looks like this. Okay. So what I'm looking for is this region right here. Okay? So all I'm going to have to do here is do the integral from left to right of top minus bottom. Now, if you can't sketch the graph, right, even on multiple choice, right, if you look back at when I did this, on the multiple choice section, I would have sketched a little graph there. Sometimes they'll provide a graph for you, but they won't provide any intersections, and you need to figure those out on your own. So I know I need to do the integral from left to right of top function minus bottom function, but I need to figure out where those intersections are. Now, one intersection should be pretty obvious, right? It looks like that left intersection is at 0, right? Both of these functions have a y-intercept of 0, so I'm figuring that that left intercept is 0. Now, you also should be able to deduce what the right intercept is as well, just because these functions are so simple, right? Well, because 1 and 1 squared are the same value, I'm guessing that my intersections here are going to be at x equals 0 and x equals 1. But what if it's not so obvious? How do we figure this thing out? Well, what we're going to have to do is figure out in our head, how do I find this point and this point algebraically? Okay. When I want to figure out where those two graphs intersect, what I do is set those two graphs equal to each other. So just to confirm, again, my guess here is that my answer is going to be x equals 0 and x equals 1. But to solve this, I need to set the two functions equal to each other. Right? So this always works, right? And it's good to be 100% certain of your intersections, because if your intersections are wrong, then your answer is going to be wrong. So all I do is just set these two things equal to each other. I'm going to say x squared equals x. Okay? Anytime I have a quadratic and I want to solve it, I like to set the whole thing equal to 0, unless all I have is an x squared and a constant, right? If I had x squared equals 5, I would use the definition of square roots, right? Remember from Algebra 2? I'd use definition of square roots, and I'd say x equals plus or minus the square root of 5. But if ever I have both an a term and a b term, right, an x squared term and an x term, I want to set this plus a constant if we have it. I want to set the thing equal to 0. To set this thing equal to 0, I'm just going to move this x over, and I'm going to have x squared minus, get out of here. X squared minus x equals 0. Now, when I only have an a and b term, right? Algebra 2 is working on this right now. I was just checking out Mr. Myers' class. Whenever we have just an a term and a b term, the easiest method is simple factoring. So I can factor out an x from both terms. And I set both terms equal to 0. So I get two solutions, x equals 0, and solving this, I get x equals 1. Those are my two solutions. They're also the two solutions that I anticipated by looking at this graph. So I know this is 0, and I know this is 1. Now we're getting down to the part that's going to be nice here. So what I want to do now is I want to integrate from left to right of top function minus bottom function. Now let me show you a common mistake that students make. They look out here and say, oh, x squared is my top function. Well, be careful. It's the top function out here. But in my region, if you trace that back down, x squared is actually the bottom function. Up here, y equals x is actually the top function. So all I need to do is top function, x, minus bottom function, x squared, dx. So the solution to this definite integral will be the exact area of that bounded region, right? So these are definite integrals, so we really have to pay attention to our left and right bounds here, or our left and right intersections. Going ahead and solving this thing out, all I have to do is know how to solve a definite integral. Well, that's not too bad. Again, I could split this into two integrals. I don't think this is one that would be any faster to split into two integrals. I'm just going to go ahead and do them together. But if ever I have two really weird functions that are going to be done differently, I would like to split that integral. I won't here. It's also in ax to the n form, so it's really easy to, I can just go ahead straight to my brackets. I'm going to bump and divide, and I'm going to bump and divide. Okay. Since they don't have the same coefficient, I can't pull out a half here or pull out a third unless I split these two integrals and did them individually. So I'll just leave the half and the third alone. And what I have is half 1 squared minus a third 1 squared. That whole thing in parentheses, minus a half 0 squared minus a third 0 squared. I'm running out of room right there. Okay. Solving this thing down again, 1 squared is 1. 1 times a half is a half. And I have a half minus 1 squared, sorry, that should have been a cubed. 1 cubed is still 1. 1 times 1/3 is 1/3. The nice thing is this whole thing equals 0, so I don't really have to worry about it. All I have to do here is a half minus a third. In order to subtract these, I need a common denominator, so I'm going to multiply these by 3 and these by 2. And I'm going to get 3/6 minus 2/6, which gives me a final answer of 1/6. That is the area, right? That number right there, 1/6, is the exact area of this black region right here. Okay? Now I'm going to show you how we do this on our calculators. Now when you do it on your calculator, oftentimes these two intersections right here are going to be really ugly numbers. Okay? But that's okay because we're using a calculator. So, here's the next problem. Find the area of the region bounded by f of x equals 2x squared minus 3x minus 5, and g of x equals negative x squared plus 5x plus 1. So that's what I want to find the area of. Okay? By the way, before I solve this, I just want to talk about this. What would have happened if instead of doing top minus bottom, let's say you didn't know which one was on top and which one was on bottom. And what if you did it backwards? What if you had done x squared minus x? Well, if you would have done this backwards, right? If these two would have ended up being flipped, right? That would be a mistake that you make, could make. What would happen is we'd have 1/3 x cubed minus 1/2 x squared from 0 to 1. And then we would have ended up with 1/3 minus 1/2, again, minus 0. And we would have gotten 2/6 minus 3/6. 2/6 minus 3/6 would have given us negative 1/6. Now we know that an area can't be negative. But if you notice that the absolute value of that answer does come out to be the same as the actual answer. So, if you ever are unsure which function is top and which one is bottom, don't panic, okay? You can still get this thing right. If you're not sure which one is top and which one is bottom, just pick one of them to be top and one of them to be bottom. If you solve it and you get a positive answer, then you know that you did it correct. You chose the top to be the top and the bottom to be the bottom. If you end up with a negative answer, however, that means you chose incorrectly, and the actual area is just the positive of the answer you got. Okay? So sometimes students have a really hard time choosing, oh my gosh, which one is top, which one is bottom. I want you to think about that, and I want you to choose it right if you can. But if you can't, do not panic. Simply just assign one of them to be top and one of them to be bottom. Solve it. If you get a negative answer, you chose wrong, and your answer is just the positive, right? The absolute value of your answer. And then if you chose correct, that means you ended up with a positive number. Okay? Just a little tip, just in case, so you don't worry too much about that. Okay. Let's take a look here. So what I want to do is I want to enter these two things into my calculator. And just like on that rate in, rate out stuff, I like to label which one's which. So f of x, I'm going to enter my calculator as y1. G of x, I'm going to enter my calculator as y2. I like to keep that straight so I know which one is which, very simply, so I can properly assign which one is top and which one is bottom. Okay, so let's go to my calculator app, and I'm going to go ahead and type these two functions in. All right, I'm going to clear out the old junk that's in there, and I'm going to do 2x squared minus 3x. Oops, didn't read that. Two x squared minus 3x minus 5. That's my f. My g then is negative x squared plus 5x plus 1. Okay. I don't know exactly where these functions are going to show up, so I'll just hit zoom 6 to see what we got. Okay. It's always going to graph y1 first, then y2. So right away I know my y2 is the top function. y2 here is the top function. On my graph, that's the one in red. If you're unsure, just hit trace, right, and move the cursor so it's in the middle of the region that you see, right? And right up here on your calculator, it'll tell you which one it is. Now it's kind of nice on the color graph because I know blue is y1 and red is y2. But if you don't have a color graph, it'll say right up here which one it is. So right away, I know that my y2 is on top and my y1 is on bottom. Okay, so I know setting this thing up, I know right away that I'm going to be doing the integral. Since I know y2 is on top, it's going to be g of x minus f of x dx. And when I do that on my calculator, it should give me a positive number. Now, if you think you chose right and you end up with a negative number, you've probably thought wrong, that it was actually the other way around. Okay? But what I'm missing here is what goes here and what goes here. Those are the two things that I need to use my calculator to find. Right? What I need to be able to find here is I need to find those intersections. So watch how we'll do this. I'm going to hit second calc intersect, and I'm going to move the cursor to that left bound. I always want to get the left bound first, then the right bound. When I find that left bound, it's negative 0.610317. Now, because I'm using this number, this isn't my final answer here. I'm going to use this to get another answer. I want to make sure that I use all of those decimals. And again, whenever you do an intersection, the x is stored as answer. So what I do right away, I'm just going to write that number down. Sorry, I need to write it on my actual whiteboard here. And then what I do right away is I hit second quit, and I want to store that as the letter A. Okay? So then on my test, or on my answer sheet here, I'm going to say x equals negative 0.6103173. And then I need to let the scorers know that I'm letting that equal A. And I'll put that in as A. Make sure you write it on your sheet and properly save it on your calculator. Okay? Now I need to find the other intersection. So I'll go back to my graph and find what I'm going to call B. I'll do second calc intersect. I just need to arrow closer over to that other intersection. Hopefully you guys are getting really comfortable doing this kind of stuff on your calculators. The more you practice, the easier it gets. So my other intersection is at x equals 3.276984. Once again, I'm going to quit. And I'm going to store that as letter B in my calculator. Okay. I'll go ahead and write that back in my scoring region. So x equals 3.276984. And I'm going to let the scorers know that I'm using a shorthand notation of B for this. Okay? I never have to actually write out what these functions are. Right? I can just call them G and F to make it just less to write. But we know g ties to this function, which ties to y2 in my calculator, whereas y1 ties with f, ties with this function right here. So my last move is to get my final answer. Now my final answer, I'm going to round to the third decimal place. But what I want to make sure of is I'm not rounding these numbers along the way. You can't round until the very end. If you do, you could be off by 1,000th, which means you could be off by 1,000,000 or off by 1,000th, and it's wrong on the test. Okay? You got to be exact. So we need to do this very carefully. So now what I'll do is I'm just going to do math 9, integral from A to B. And again, I can't use A and B unless I've actually saved those things into my calculator to be the variables that I actually want. Now I have to do, okay, I'll do it on my calculator that I have here. Bad time for it to die. I'll just tell you the answer that I get after I type this in. Sorry, I was not anticipating it to die. So I do math 9, integral from A to B. Now what's important is I have to do y2 minus y1 if I want the answer to come out correctly positive. When I do that, my calculator, unfortunately you can't see, my calculator gives me an answer. See if you can get the same answer. 29.371. You could also write 29.370, but you can't write 29.37. You have to have 3 decimal places there. All right. I wish that the calculator app wouldn't have died right there, but hopefully you're able to try it on your own and get that same answer. That's it for today. Talk to you guys later. 2 chains. Bye.